Okay, so this is my more in-depth video that I'm going to go through how I went about this Rocket League project. Um, it's basically just I wanted to do it as a physics demo, like using bullet physics and with my game engine. Um, it's something that was a little bit more in-depth and looked a little bit better than just a couple of spheres rolling around or cloth made up of spheres. It's my same game engine. Um, I made a big long video about how I set this up. I might make another one now that I'm pretty much completely done with it. Um, so you can go take a look at that if you want exactly a little bit more in depth about the shaders and the design patterns and all of that kind of stuff. For this, I'm going to go through the physics part of it. So um, when I started up here, I need to, what do I even call it? Load meshes, load textures. There should be a load physics. Anyway, I don't know where I call this. Maybe it's in my main loop. Anyway, doesn't matter. I call this load scene. So I load the physics. I have some AI physics that's for a different part. I'm not going to be doing that. And different here. So this random physics is just my catch-all simple physics thing. So if I need to put in something that's super simple, I just need a ball to bounce on the ground and not look, doesn't matter really how it looks, I can add it to random physics. So that's what I use for the goal explosions and the boost. Um, I'll add them to, I'll use this C physics engine that's called this to integrate, like it has integrate, so P random physics integration step, and then I can put in a vector of the objects I want to integrate in my delta time. So I call that in my main loop. I'll probably get to that later, and I just make sure I have all of the boost objects and the explosion objects in a vector and pass it in there. So this is my more in-depth physics library. I'm actually not using it. I switched it over to Bullet for this demonstration, so I'll be using the Bullet physics library instead of my own physics library. It's just much more in depth. It has like local inertia and all that kind of stuff that would take forever to implement myself. So anyway, this is all like function pointers to be able to load a factory because I need a concrete factory to make a concrete world. But other than that, I don't want to be able to make concrete objects. I just want to be able to make the interfaces. These are the interfaces like vehicle interface, vehicle component, ball component, plane component are the ones I'm using in this. Plane component. So that's why I need that. I'll get into this where I load the objects. So this is multi-threaded. So I load them all on a separate thread. Except for, anyway, yes, I load them all on a separate thread. There's a little bit of exceptions to that, but I won't get into that. So here's my main car. I make a sphere object, which that's just for my old physics engine. I just have the I object inheriting everything right now. But this is the one I'm actually going to care about, is the component type here. It's a vehicle component. I found online a Dominus GT body from Rocket League, so I'm using that, and the actual wheels too. Found it online for free, so I'm using it. This is the graphics component stuff. I've been over that in a separate video, so I push back the graphics component into a vector so that I can render the rotation and the scale. And then so after that, I need to make a vehicle definition object. It's like a struct. So it just has a position, width, and mass. When I go in to this vehicle def, I'll show you what happens. So I got that, it's part of the iVehicle component. So I've deleted these constructors for making a vehicle because I only want to make a vehicle if I know what I have. Like I need a definition on it. And so this is the interface. I need to go to the actual. Let me open this up. See vehicle component. So I've deleted the other constructors because I want a vehicle def. I also copy and pasted the name of this. It's probably right in the CPP, but when you make a vehicle, you need the world as well. So I'll go in here and show you what happens. I have this def that I pass in. When you do a box shape, it takes half width, so I just multiply it by half, and then I need to set the origin to the position, and do the mass, make sure it's not mass is 0, so if it's static or not, calculate the inertia, local inertia, so that's a big part of why Bullet is really great compared to my own physics engine, because I don't have anything close to that. So set my motion state. It's just a bunch of basic, like setting up the actual Bullet stuff. So I need a user pointer so that I can access it for there's a bunch of different reasons. So what I use it for is ghost objects and collisions and stuff. Oh no, wait, sorry, that's a user index. I'll get into that later probably, not user pointer. User pointer is just kind of like a utility function that you can use. So then I have a vehicle raycaster, raycast vehicle. So after that is where I make the wheels. So I should go back to this load scene, because before I actually make it, I do all of the wheels. So down here after the wheels is where I actually pass the def into creating a vehicle through the factory. And so I just go through, do the graphics components for the wheels, and then make the physics wheel. And depending on which wheel it is, I do different positions. And if it's a front wheel or not, I also have to do that on the graphics component, because I can't remember why. I don't know if I just can't, oh yeah, because I can't access this def after I make the physics component, and I wanted to be able to know if it was a front wheel or not, because I wanted to do separate scaling and stuff, and so that's why I did that. And I set the rotation to 0. On this one I have to set it to 180 degrees around the other way, because then you'll see the outside of the tire instead of them being the wrong way. Same with back wheels. Yeah, then I add the wheels to the physics vehicle definition, and then add the wheel object to the graphics vector for the wheels. And then after I've done all 4 wheels, I create an actual vehicle component and add the vehicle component to component objects vector that I will be able to render. And then I set the component to this so I can access the component in runtime through the object and add it to the physics world. So it's a bit complicated there, but if I go back here, this is where I need to make the connection points, and I add the suspension length, the radius, axle is front wheel, all of that stuff to the actual def that Bullet Physics is going to need. So they match up pretty closely, like dampening and relaxation, dampening, compression, friction, roll influence. It takes a bit to tweak all of this to get it to look right. Like when I first did it, it would like bounce around in a circle off the suspension and be really bouncy and stuff. So it took quite a bit of fine tuning to get it to just hit the ground and stop, kind of like in Rocket League. Yeah, so I load that vehicle and the wheels in, and the ball component is super easy. I just found a soccer ball texture and put it over top. This is the soccer ball. I just make a ball depth, mass of 1, so it gets hit around no problem because the mass car is like 400, I think. This is AI stuff. This, okay, here it is. Oh, it's 200. So anyway, still, it's hit around no problem because 200 is way more than 1. Then I just set the radius and everything like that, scales, and set it up in the air so it falls down right away. Yeah. And then in my main loop, it's all in the second pass here. So I have my bullet physics world update. So anything that's added to my bullet physics world will update in the physics world. So it's pretty straightforward. Then I also need to do my random physics integration step with my boost objects and my explosion objects. This is for AI stuff. I'm not using it. I should probably just comment it out, but I didn't. And slow things down, and then these are for off-screen rendering. I'm not actually using it in this project either, but it's for if you're interested. I have another video on that. Yeah, and then that's about it. So if I'm colliding with the goal, then I do an explosion, and that's about it. I'll show you how it runs here. So I can actually jump to you. Whoa. You know what? I think I had the mass way higher before. I'm going to need to change that. So, might as well go and do that now while I'm recording. If I go into my inputs, and my fly camera, and then I have my inputs. So if I have control down, and I'm rendering, so if I control keys down, and I'm not rendering AI, if I press space, apply force up, I'm going to take 2 zeros off that, and 4,000 forces. I don't know. Let's see. Oh, it doesn't get it off the ground. Anyway, you can see how I've got this set up. If A and stuff is down, then I do different things. So that's how I did like the gradual steering on the front wheels, so that it doesn't just snap into position. I did it so like if this was pressed down, I add some degree of rotation until it's there, and then it snaps back when I let go. Yeah, same with acceleration. So I apply 0 force eventually. So yeah, that's about it. It was a little bit technical. Like the biggest part was getting all of the vehicle stuff set up, especially with the wheels, and getting them where I could actually like access them and apply rotation properly and everything like that. So actually in my main loop, I also apply, so I should note this, like I apply engine force to wheels 2 and 3 because 0 and 1 are the front wheels, and they do the steering, and so this is rear wheel drive. Yeah, and so I apply the engine force, less engine force until it's like close to 0, and same, I minus off some turning radius from 45 down to 0. Yeah, so that's about it. doing this transfer over and getting all of these settings right was the biggest part of this, but it's all just pretty much learning how to use the bullet physics engine. Once you know how to do that, that's just the biggest part of this for sure, and then getting all the settings correct and just actually putting it on the screen. But the biggest, most tricky part is learning how to use bullet physics engine. Yeah, so that's about it. Thanks.